Welcome back to Mr. B's math class. Today we're going to look at 11.3, determining probabilities using fractions. So our student outcomes for today are I can solve probability problems and I can verify my answers using different methods. As we've worked our way through Unit 11, you'll have found that we've been learning different ways to solve probability questions. And that's the best part for today's lesson. Now you're able to kind of take what you've learned and use whatever's going to work best for you. So let's look at our first example. So example 1, it says Andy spins a spinner divided into 5 equal regions and rolls a 4-sided die once each. The first question says, what is the probability of us getting a blue 2? Now remember, when we look at our die, even though we only see 3 and 4, there still is 1, 2, 3, and 4 available. Well, we know we could easily, for number 1 here, I'll just do 1 here, we could, do the colors purple, green, yellow, red, and blue, and break this up by, going 1, 2, 3, 4, and work our way into a tree diagram, which would work. But the easier way we can do this now is building off of 11.2 and using multiplication. So when we look right now, and I'm just going to separate this here, so we have this 1. When we look at our spinner, we're going to kind of break it down to 2 probability questions. So the first part says, what's the probability of getting blue? Well, when we look at here, there's 1 blue out of how many total? Well, there's 5 possible outcomes. So we have a 1 out of 5 chance of getting a blue on the spinner. And we're going to multiply that probability by the next one. We're looking at a 2. Well, on that die, there's only 1 2, so we have 1 chance of rolling a 2 on that die, and there are 4 possible outcomes. So if we multiply our probabilities together now, that gives us a 1 times 1 is 1, and 5 times 4 is 20. That gives us a 1 in 20 chance of getting a blue 2. So it just really saves us a lot of time, whereas you still could easily do your tree diagram like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And if we look at it right now on this diagram, blue 2, well, blue is right here, and there's only 1, 2, so we'd have a 1, and if we counted them all together, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to the top, it would still be 1 out of 20. So if that works best for you, you can definitely do that, but if you're looking to kind of speed things up a little bit, you can actually use the other method, which is our multiplication method. So let's look at our second example here. What is the probability of getting red or blue and even? Well, again, we've got to do our probabilities of each event here. So what is the probability of getting red or blue? Well, we have red and blue here. Well, there's 2 of those out of 5 possible options, being yellow, purple, green, red, and blue. So we have 2, because red or blue is 2 of the options. And we're going to multiply that probability by even. Well, on the die, we have a 2 and a 4. Well, there are 2 possible even numbers and still 4 total numbers on that die, 1, 2, 3, and 4. If we were to multiply this together, 2 times 2 is 4. And we're going to find that 4 times 5 is 20. So we have a 4 out of 20 probability of getting that answer. If we were to narrow that down even more, we could divide 4 by itself and 20 by 4, and we would get a 1 in 5 chance. So our probability of getting is 1 in 5 if we're looking just for a fraction. So that's how you can use multiplication to solve your answers. Now let's take a look at our next example. So example 2 says Leanne rolls a standard 6-sided die and Grishel spins a spinner with 3 equal sections. Now, sorry, the only picture I could find that had something like this does not depict both the people in this example, but that's okay. What is the probability of getting an odd number and spinning a bee? Well, again, we could do that tree diagram or a table, but for this lesson, I'm going to stick to multiplication. So let's start with the first part, our odd number. Well, we know on that die, the 6 sides, there are going to be 3 odd numbers possible on a 6-sided die. We're going to have 1, 3, and 5. So our favorable outcome is 3 out of, and on that die, there's 6 sides. So there's 6 possible outcomes on that die. We're going to multiply that probability by the next event, which is spinning the 3 equal section spinner. And it's saying spinning a bee. Well, we can see that there's just one bee there, so our favorable outcome is 1. And their total outcomes, A, B, and C, there are 3 total outcomes. So if we're going to multiply this together, we would have 3 times 1 is 3, and 6 times 3 is 18, giving us a 3 of 18 probability of getting an odd number and spinning a bee. However, we can still break this down by dividing the top and the bottom. 3 divided by 3 is 1, and 18 divided by 3 is 6. So we have a 1 in 6 chance of actually spinning that bee and getting an odd number. So now let's take a look at our third and final example. So example 3, first thing we're going to look at here are just 2 terms you're going to notice in your assignments. The term experimental probability and theoretical probability. So let's just start with what each one means. So experimental probability, well, this is the probability of an event occurring based on experimental results. What this means is you've actually done the experiment. So for example, if it asks, like in that first question, you're spinning the spinner and rolling the die, it means you yourself actually have a spinner and a die and are actually doing the experiment to see what the outcome is. So it means you would actually have been spinning it so many times to see if you were going to get blue and then a 2, and you would have tried that multiple times to see if it works. So we haven't done that yet so far because we haven't actually had to do any of the physical problems. But that's what experimental means, is it just means you were actually doing it. Or theoretical probability, the calculated probability of an event occurring, means we haven't done it but calculated it, and that's what we've done so far. When we had questions where it said, what's the probability of getting blue and a 2, well, we didn't actually, in that first example, spin a spinner that went blue and then roll a die. We just said, okay, well, there was 1 blue option out of 5, and there is 1, 2 out of 4. Oh yeah, that gave us a 1 in 20 chance. This right here is our theoretical, because we're kind of calculating it what we think it's going to be, but have not verified it by actually doing the experiment. So that's really important to understand the difference between these two. So with that being said, let's take a look at this question. So example 3 says, Jansen is planning the time needed to get to his volleyball game. There are 2 traffic lights between his house and the gym. These lights are red 3/5 or 60% of the time. Jansen wonders how likely is it that both lights will be red on his way to the game. So wondering if he's driving to the game with his mom, what is the chance that both lights are going to be red that he hits them? Well, right now, if we're doing this theoretical, we could simply just use multiplication or sample space to get our probability. So let's do that right now. So it says these lights are going to be red 3/5 or 60% of the time. So that means that light 1, let's call it here, is going to be red 3/5 of the time, and light 2 is also have the probability of being 3 out of 5 red. Well, the probability of them both being red, we still have to multiply them together. That's our theoretical probability. So 3 times 3 is 9, and 5 times 5 is 25. So we have a 9 in 25 chance of those lights being red at the exact same time when he hits 1 and then down the street the next light. Now, if we were to turn this into our decimal and fraction, if we divided 9, our numerator by denominator, we're going to get a decimal of 0.036 and then a percent of 36%. So we theorize based on that fraction that both lights he'll hit have a 36% chance of being red both times. So that's our theoretical probability. We haven't tried it yet, we've just calculated. Let's take a look at our experimental probability. So same question, but in this situation, Jansen wanted to actually test out his theory. Now, rather than just drive and hit the lights and just count that each time he went, he created an experiment that he could do that would still symbolize the results of what he was looking for. So what he did is he created a spinner here, as you can see, with 3 red lights, and then 2 green lights. So the idea here is that if he spins these, twice, first and then second time, and then would double check to see what his results were. So for example, when he spun it the first time, he got red, and followed by the second time, it was red. So both lights were red. Yep, that happened. Then he did it the second time, and it was green and then green. So they both weren't red. And he's done this multiple times to find out, just out of a sample of 10 times, to see what that probability could be if he tried it out. And he's found here that his probability here, he did it 10 times. 3 of these times, both lights were red like he was looking for, out of 10. So he found that it was actually a 3 out of 10 chance of those lights being red both times because he's done this experiment. Well, if we make that into our decimal, it's 0.030, and as a percent, it's 30%. Well, our experimental probability was 30%, but it differs slightly from our calculated one in theoretical because we found that it was 36%. Now, to be fair, there is a difference in what we kind of calculated versus what he actually tried, but he only did it 10 times. The more times you do a probability experiment, the more accurate your results are going to be. So 10 times, yeah, that gave us a good example of 30, and they are pretty close. But if Janssen was to do this, 100 times or 1,000 times, we might find that these two numbers get a little closer. So there will probably be a difference in our experimental to our theoretical. The more times you do something in science or math for experiment-wise, the more accurate your answers are going to be. So that's pretty much what you're looking at for today. When you get to the questions on your assignments, just remember that experimental, you're actually going to have to design an experiment to check your answers. And theoretical, you're simply just doing what we've been doing all unit long. So that's it for today. Good luck with your assignments, and we'll check in later.